Hi guys, and welcome to 2-2, Finding Slope and Rate of Change. Easy peasy lesson for us today. Our central question, how are the slopes of perpendicular lines related? Basically, we're going to be talking about the slope of a line, which in words is your vertical change over horizontal. Okay, know that much. It's always vertical distance over horizontal, also known as rise over run. When you hear the words per, so like miles per hour, that really is a rate of change as well. Rate of change is, all these things mean slope, okay? The formula for slope is m equals y2 minus y1 all over x2 minus x1. Those come from coordinate points. You guys have likely done this before, so hopefully it's not too challenging. But they come from coordinate points. The main idea is that your x's and y's are on top of one another from the same point. So here's the blue point, and here's the purple point. They're horizontal here, but they flip on top of each other. So you can actually also have y1 minus y2 all over x1 minus x2, so long as the y2's are on top and everything like that. Okay. Graphically, if we look at this graphically, it's the change in the horizontal and vertical, and your slope just connects the 2 points there. Okay, so when can you use slope in real life? A skateboarder, there he is, man, has a rise vertically of 15 inches and runs horizontally 54 inches. Okay, so really what's going on here is it's saying that the skateboarder, for every 15 he goes up, he goes over 54. That's where he starts. So this is 15, this is 54, horizontal, vertical. What is the slope? Well, it may not look like it, but we actually have two coordinate points. If we think of the start of the ramp as the coordinate 0, 0, there is our first x1 and y1, 0, 0. Well, where do we get the second one from? Well, that's the top of the slope. So this point here is actually 54, 15. And plot that into the slope formula. We have 15 minus 0 all over 54 minus 0, and that's going to equal 8/15. So basically what it's saying is for every 8 inches vertical, 15 are crossed horizontally. Okay, I know you couldn't see that. So for every 8 inches vertical, 8/15 are crossed horizontally. Classifying slope in special lines, really not too crazy here. Basically, it's going up left to right. It's a positive slope. We call it rising. If it's going down from left to right, it's a negative slope, or falling. If it's horizontal, slope is 0, and it's straight across. And if it's a vertical line, slope is undefined. Okay? How these look as equations. Know this here. Horizontal lines are always in the form y equals some number. Okay, so y equals -10, y equals 50, y equals 1/2. These are all horizontal lines. Vertical lines are always x equals some number. So x equals 10, x equals -50, x equals 3/4 are all vertical lines, just one letter for each of them. Parallel lines have the same slope. For example, if the blue line has the equation y equals 3x plus 5, the purple line has to have the equation y equals 3x maybe the y-intercepts are different. The slopes, though, for parallel have to be the same. For perpendicular, and if you aren't sure, perpendicular means they make a right angle. Their slope has to be opposite of one another. So like positive, negative, and reciprocals. So A over B, B over A. Example. Let's say that line 1 has the equation y equals 3x plus, well, negative 3x plus negative 5, no big deal. And this one would have to be then y equals 1/3 x, and it can even be minus 6. The key thing is that these slopes have to be opposite. So if I have m equals 4, perpendicular slope would have to be negative 1/4. If I have m equals 6/7, perpendicular slope would have to be negative 7/6. Okay, we'll practice with that in a bit. Find the slopes of the lines passing through the given points. Tell whether a line rises, falls, horizontal, or vertical, and determine if they're parallel, perpendicular, or neither. Line 1, so basically we're just going to be finding the slope. So negative 2 minus 5 all over 3 minus 1. If I'm going too fast, all of this is coming from the points. Label them x1, y1, x2, y2. Okay, that gives you negative 7 over 2, and that's the slope. Now, is it positive, negative? Well, it's negative, so it's a falling line. Okay. For the next piece, line 2, and I actually have a typo here. We want to fix this, okay? It is going through the point 7, 6 and the point 0, 4. Make sure you fix that, or you will not get the resulted answer. That is 0, 4, not 4, 0. So what's going to happen is you're going to turn these notes in, and no one's going to have that fixed. And I don't know if you watched or not. So slope is 4 minus 6 all over 0 minus 7. Well, that gives me negative 2 over negative 7. Negative over negative means positive. And at this point, I know that the line is positive, so it's rising. More specifically, how do these two lines compare? Line 1 and line 2. Line 1's slope is negative 7/2. And line 2's slope is 2/7. Well, what does that mean? That means they are opposite reciprocals. So these two lines would be perpendicular. Yep. Okay. Last piece, average rate of change. That just means slope. Okay, so pretend like this is x1 and y1, x2 and y2. Now as we set these up, it also tells us x is measured in hours and y is in dollars. Actually, we should do green for dollars and we'll say purple for hours. Okay, so just be aware that when you do your slope, you have dollar amounts on top and you have hours on the bottom. Okay, so this is actually going to tell you, it's going to tell you the cash per hour. Okay, that is what I'd like you to find, the average rate of change or average salary per hour of these ordered pairs. Be sure to include that, and that'll be in the end. Key thing again to know, perpendicular lines, parallel lines, what x equals, what y equals, what types of lines, so vertical, horizontal, and also rate of change and all that. So thanks for watching, guys. Awesome stuff, and we'll see you.